This video is to review the problems from the Edulastic major that you guys had due for me the other week. I wanted to make sure that I reviewed the questions so you could see exactly what the correct answers were and how those answers were found. So up on my screen, I have the questions in order according to the Edulastic view, and I'm going to go through them one at a time. I also have my Elmo camera set up here so that I can easily show you what I'm writing as we're going through these problems. So, the first problem in question asked for the factored form of w squared plus 18w plus 77. Now, a lot of these problems you may end up seeing as, oh, well, I got that one correct, no worries, no problem. But I wanted to make sure that I did this nonetheless. So I'm looking at this first problem, and I could go through the Tucker method if I wanted to. There's nothing to solve for, I just have to factor it. A times C here would give me 77. Now, you don't even really need a calculator for this. I'm just going to show you on the calculator how you could have done it. But you're looking for two numbers that multiply to 77 and at the same time add up to 18. Now, in this case, 7 and 11. 7 and 11 multiply to 77, and 7 plus 11 add up to 18. That is why those two numbers work as your magic numbers. You could do a T-chart if you wanted to, although because it's a 1W and a 1W, you really don't have to worry about a T-chart because there's nothing to be simplified here. Ultimately, you're going to get W plus 7 and W plus 11. Now, if you go back to the questions, it does not matter the order in which these appear. It could be W plus 11, W plus 7. Multiplication is commutative, but the answer here should have been that third option. Going to the next question. Question number 2. They're asking for you to solve this. Now, just for the sake of argument, I am going to write this down on my piece of paper. But the wonderful thing about number 2 is that it is already factored for you. And since it is already factored for you, all you have to realize is, well, there's something times something equal to 0. Zero product property. I would have to take each of those terms, set them equal to 0, and solve, which would give me answers of positive 8 and negative 2. Now, this is not an ordered pair. These are two separate answers that would make the equation true. If you go back, clearly A cannot be the answer. A would be simplifying that or multiplying those two terms together. And if you notice, B, C, and D, they are not parentheses, meaning it's not an ordered pair. The answer, once again, is actually the third option, the set negative 2 and positive 8. Does not matter what order they appear in. Looking at number 3, there's nothing to be written here, so I'm just going to verbally talk about this one. What is another word that describes the zeros of a quadratic function? Every time I've talked about the solutions to a quadratic function, I've mentioned the 4 different ways that you could name the answer. One of them being solutions. You could also call them roots. You can also call them x-intercepts. You can also call them zeros. And in this case, it has to be the x-intercept that actually identifies what the solution or the zeros of the quadratic function is. Every time we've talked about that, I've either verbally spoken out those terms or wrote out those terms. I know I did at least for our notes. For problem number 4, they're asking for you to solve this quadratic. Now, for number 4, I am going to write this one out. 3x squared minus 4x minus 7 equals 0. Everything is set equal to 0. It is your job to factor and then solve. Well, step 1 of the Tucker method, take out a greatest common factor, which in this case is a 1, so I don't have to do anything. So I am going to proceed with A times C. A times C gets me negative 21. My job is to find 2 magic numbers that multiply to negative 21 and add up to negative 4. And lo and behold, 3 and negative 7 fit that bill. They multiply to negative 21. They add up to negative 4. Now for this one, I do have to do a t-chart where I put my magic numbers in the bottom. And the reason being is because of that first term, 3x squared, which I am going to break up as 3x and 3x. Now they're not going to stay that way because it's t-chart / simplify, which in this case, 3 over 3 reduces to a 1 over 1. You got to have a number in the bottom. Vertically, this is a 1x plus 1, and this is a 3x minus 7. Now, we are not done yet. We're done with factoring, but we're not done with solving. In this case, you would have to move this up a little, set each of these terms equal to 0 and solve them individually, getting you the following two answers. Now, on Edulastic, they did have you actually write in these answers. I did check those answers that you guys got. A lot of you didn't write out the fraction properly. You could write the decimal, and I did accept that as well, as long as the decimal was accurate. That decimal would be approximately 2.67. So 2.7, 2.67, 2.66, something along those lines. I did look. Number 5. Number 5 says to solve the equation, select all answers that apply. Now I'm going to switch my paper over so I have a blank sheet of paper here. This is select all that apply. You have to be very careful here because it is not just one answer for this problem. So let's see what happens. Now I'm looking at this particular problem. It is not equal to 0. To solve it, you're going to have to get it equal to 0 by adding the 3x over and subtracting the 10 over. Once I have it set equal to 0, then I can begin to solve this problem. Solving this problem, again, using the Tucker method, a times c is negative 10. I'm going to find two magic numbers. Looks like 5 and 2 because the difference is 3, but the 5 has to be positive. The reason being is 5 and negative 2 give you that positive 3. You always have to pay attention to the positive and negative signs. Now I'm going to skip a t-chart here. The reason why I'm going to skip a t-chart is because it is a 1x squared, and nothing would simplify in the t-chart. So instead, I'm going to write out x plus 5, x minus 2 equals 0, which again, I'm not done because they still need to solve. So I set each equal to 0, and I'm going to get two answers. Now, I got to double check what Edulastic said about those two answers, because it did say check all that apply. If I look back at Edulastic, yes, I'd have to select the negative 5 and the positive 2. For number 6, they wanted you to factor and solve. Now, obviously, there's no work that you could show me on this. You could solve this any number of ways, but I am going to follow the directions and factor it, and then you'd have to type in the answers. There's no C value. You have to assume that your C value is a 0. Now, you could do this problem one of two ways. You could still technically follow the Tucker method, and you would get the answers that we're talking about. You could, of course, just take out a GCF of x and get your two answers. So actually, let me show you that one way right here. If you took out x as a GCF, factoring would be done. Set each term equal to 0, and you're going to get your two answers here of 0 and positive 5. That's one way of doing the problem. Now, if you wanted to go through the full Tucker method, because that's what you're familiar with and that's just what you want to stick with, you can do that. You just have to be very careful, because your A times C in this case, your C is a 0, would indeed be 0. And then you would be finding two magic numbers that multiply to 0 and add up to negative 5. Now, technically, again, you don't have to go through all this, but you can if you wanted to. X plus 0, x minus 5 equals 0. At this point, you pretty much have the exact same problem as you had up there. You do. But you could set each equal to 0 and solve, ending up with the same answers that we needed. Which again, if you look here, you had to type those in. Let me switch it over to number 7. Get a new piece of paper. Here we go. Check all of those that are factors when you factor out the GCF. Now, you have to be very careful here. Let's start with the first one for number 7. For number 7, they gave us a 12x plus 16. Now, for the 12x plus 16, this is not a quadratic. You can't do a times c here. But when they tell you to factor, GCF stands for greatest common factor. You're going to have to take that out if you want to factor here, which in this case would just be a 4. Once you take out that 4, this is factored. 4 and 3x plus 4, which in this case, let's see if I can click this. 4 and 3x plus 4 would be the two factors of that particular problem. Now, if I look at the second one is indeed a bit more complicated. For this second one, yes, they all have a 5 in common. And I'm not really a fan of having that negative out front, so perhaps I'm going to take out a negative 5. Let me just look at the answers that they gave me. Yeah, I'm totally going to take out a negative 5. But negative 5 is not your greatest common factor, it's just a common factor. They all also have an x in common. Negative 5x is the greatest common factor that you're looking for. If you divide each of those terms by negative 5x, you end up with x squared minus 2x plus 6. Now, you could attempt to do the Tucker method with the resulting quadratic. You could try to factor the resulting quadratic, but you can't. It's not actually possible. So, looking here, there's your negative 5, and there's the second term, or the negative 5x, and there's your second term. That's what should have been selected. For number 8, they want to know what are the solutions. Just another way of wording the problem. Let me write down number 8. Now, they did use a z, which is fine. You don't have to worry too much about it being a z. If you notice, when I write my z's out, I usually put that little line in the middle so that you don't confuse them with 2's. But notice the first step that I'm doing here. The very first step that I'm doing here is I'm taking out that greatest common factor of 3. I take that out, it makes my life a lot easier. If you want to change the z's to x's, by all means do that, if it makes it easier for you. But now your new a times c, your magic numbers, you could do a t-chart, but again, it won't simplify. Z plus 2, z minus 1, that 3 is still a factor, equals 0. Let me just see real quick. Did the problem ask me to solve? Yeah, it just asked for the solutions. That 3 is not going to factor into the solution. The first term will get me a negative 2. The second term will give me a positive 1. Those are the two solutions that we are looking for. Again, set those terms equal to 0 and solve. You set z plus 2 equals 0 to solve. You'd subtract 2 to get your answer. You'd add 1 to get the other answer. Looking at number 9, they just want you to factor completely. They don't want you to solve. They just want you to factor completely. Now, at first glance, I can see that my GCF is just going to be a 1. Even though 6 and 10 have a 2 in common, the 11 does not have that 2 in there. So let's just see what happens. A times C is negative 60. I have to find two magic numbers that multiply to negative 60 and at the same time add up to negative 11. Now that may seem a bit daunting, but after a little bit of investigation, let's see, 60 divided by 6, 60 divided by, no, I already did 12. I don't think I can do 8, no. 60 divided by 10. One's got to be, oh, I said 10. One's got to be negative and one's got to be positive here. Something's going on here. We need to investigate this. Let me list out some pairs, and let's just see what happens. I could do 1 and 60, but clearly neither of these are going to work. I could do 2 and 30, but again, neither of them add up to 11. I could do 3 and 20. Nope. 60 divided by 4. Oh, there we go. Now, again, I just listed these out just for the sake of argument. But 4 and 15, with the 15 being negative, is the one that I need. Again, it does take a little bit of investigation, and sometimes it's not going to be very obvious. But eventually we found that pair. Didn't take us that long. 4 and negative 15. It would be a 6x and a 6x that I'd have to put in the top of the t-chart. Simplify. Divide by 2, divide by 2, divide by 3, divide by 3. That negative stays on the bottom. I'd get a 3x plus 2 and a 2x minus 5. Now, the problem just wanted me to factor. That's all that it wanted me to do. Factor completely. Now, the order in which you write that is okay if you write it in one of two ways. You could write the order as 3x plus 2, 2x minus 5, or 2x minus 5, 3x plus 2. Either way is acceptable for this particular problem. And of course, you'd write that into the box right there, or type. Number 10. Looking at number 10, they want me, okay, if you factor completely, which of the following is one of the factors? All right. 2x squared minus 7x minus 4. If you factor completely, what is one of the factors? All right. GCF is 1. A times C is negative 8. Looks like negative 8 and positive 1 are my magic numbers because they got to add up to negative 7. 2x and 2x, negative 8, positive 1. I'm going to have to simplify here. That'd be a 4. Keep the negative on the bottom. Looks like these are my two factors. Now, I haven't looked at the answers that they gave me. Yep, it's just the 2x plus 1. Because they didn't ask for all the factors, they just wanted to know which of the following is one of the factors. Number 11. What are the solutions to this particular problem? Now, barring some guess and check action that you may end up trying for this, simply because guessing and checking may or may not be in your best interest, looking at this problem, it's not equal to 0. I'm going to have to get one side equal to 0. Subtract 100 from both sides, and you end up with this. Now, again, I'm going to go to my calculator because I'm like, okay, 108. I got to find two numbers that multiply to 108 and add up to 21. 108 divided by 2, definitely not. 108 divided by 3, nope. 108 divided by 4, no, those adds up to 31, but we're getting closer. 108 divided by 8, nope, it's a decimal, forget that. 108 divided by 6, those add up to 24. We're getting a lot closer. 108 divided by 12, there it is. I don't know why I skipped 9, but A times C is 108, and my two magic numbers got to be 12 and 9. They got to be 12 and 9. They got to multiply to 108. They got to add up to 21. T-chart, not necessary because it's a 1x squared. So it would be an x plus 12, x plus 9 equals 0. Now, did the problem ask me to solve? Yes. What are the solutions? Set each equal to 0, you would get an answer of negative 12 and negative 9. Those would be your solutions. Let's take a look at number 12. Number 12, when x squared minus 9 and x squared minus 5x plus 6 are factored, a common factor is, interesting. They give me two different quadratics, and they want me to factor each of them, and then they want me to identify what factor do they have in common. With the top one, x squared minus 9, if you went through the Tucker method, which I'm going to bypass for now, you would end up with these two terms. 3 times negative 3, 3 plus negative 3. If you were to factor the bottom one, you would end up with this. Negative 2 times negative 3, negative 2 plus negative 3. They work. Now the question was, a common factor is, it's got to be x minus 3. That's what they have in common. You can see right here, x minus 3 is that solution. Let's look at number 13. A quadratic in standard form, or which quadratic in standard form would have x-intercepts of negative 3 and positive 8? Now this is interesting. Actually, you know what? I'm going to go to a new sheet of paper. I'm going to go to a new sheet of paper for number 13. They have x-intercepts of negative 3 and an x-intercept of positive 8. Now, for this problem, it's basically working backwards. Assume for a moment x-intercepts are your solutions. X-intercepts are your zeros. X-intercepts are your roots. X equals negative 3. X equals positive 8. Let's work backwards. Literally do the problem backwards. If I were doing the problem backwards, I would solve getting those answers. Before the zero product property, they would have looked like this. Multiplying those two terms back together, I end up with the following, because I'm basically working my way towards this quadratic after combining like terms. There we go. It's basically the problem upside down. Typically, I would give you this quadratic to start with. You would factor it into the terms. You would set each of the terms equal to 0 and solve, thus getting the x-intercepts that they originally said that they had. There it is. Option B. It's the quadratic that we ended up getting. Finally, number 14. Now, number 14 wants you to solve the following by factoring. 3x squared minus 26x equals 9. Now, they do give you a none of the above option. We'll deal with that in a minute. I have to get one side of the equation equal to 0 by subtracting the 9 from both sides. If I'm looking for a GCF, I would love to take out a 3, but that 26 does not have a 3 in common. So A times C is negative 27. Now, if you recognize how to get this for the magic numbers, it's actually a very simple case. It's just that you have to realize that 1 can be used as a magic number. They add up to negative 26. They multiply to negative 27. I definitely have to do a T-chart here with a 3x and a 3x. Simplify. I end up with x minus 9. And 3x plus 1 equals 0. Now, I believe they did want me to solve. Yep, solve the following. The first one, x minus 9 equals 0, you would get a positive 9 as a solution. The second one, be very careful, you have to subtract 1 and divide by 3. So you'd get the fraction negative 1/3. There's no other solution that you can get besides these two. And if you looked at the graph of this original problem, you would see that it only crosses the x-axis twice. For this problem, it has to be this solution right here. I hope that going over these problems has been helpful for you. And if you have any remaining questions, please make sure that you are asking. Email me, message me, do what you got to do. Thank you.